I added touchscreen controls and rotation to my WASD character controller so that desktop and mobile players can duel each other in the top-down PvP sword-fighting action game that you're watching me build. In this video, I'll share how I use raycasting to solve 2 of the 3 issues with the first draft of the movement system that I created last episode, to rotate our characters based on pointer position and to add the missing touch controls, some game design considerations for a combat system that's fair to both desktop and mobile players, and how I plan to solve the 3rd issue of integrating my character controller with this hex grid in the episode after this one. As always, there's a playtest for you to check out in the description, which you can try without installing anything. That's the great thing about JavaScript. Welcome to episode 3 of my devlog series on making a game incrementally. And now, let's get into the code. The most notable addition to the codebase is this RaycastPlane component. Aside from UI elements, this plane is the only object in our 3D scene that players will directly interact with. So, what is raycasting and why do we need it? Well, normally, when we use event handlers from the browser to get the pointer's location, the X and Y coordinates are based on the screen position, which isn't very useful for us because we're working in the context of a 3D scene. Raycasting is a technique that sends a virtual ray of light from our camera to our pointer while telling us which 3D elements intersect with that ray. We use this to get the ground plane coordinates of the pointer. For us, that means X and Z coordinates and not Y, because in Three.js, the ground plane is XZ and the Y-axis is the vertical one. It's arbitrary, but if you're coming from Blender, where the Z-axis is the vertical one, don't forget to take Y up when exporting models to use in Three.js. So how are we going to add raycasting? We create a plane made of 2 triangles. Make sure that it's large enough to fill the full viewport. My game will have a fixed camera, so this should be enough. Then every time we render a frame, pass the plane to the raycaster. I don't pass the whole scene because for my game, all pointer interactions in the 3D environment will happen through this plane, but you might have an idea that requires checking for intersections with multiple objects. Then, if the ray from our camera view to the pointer intersects with the plane, we store the X and Z coordinates. For keyboard and mouse, I only store the coordinates when left click is held. For touch, there's some additional work. I store the coordinates of the initial tap along with the later coordinates from dragging so that I can compute movement direction based on which way players drag their fingers. Believe it or not, these 4 variables are all we need to upgrade the movement controller, but before we do that, let's go over 3 parts of the codebase that I refactored. The first refactor is that I previously put each state store in the same file as its relevant component, but unfortunately, having multiple exports in a component file breaks fast refresh in the development environment. While this has no effect on the build for end users, having to manually refresh during development gets really tedious, so I moved the component state stores to their own directory. The second refactor is that I removed all usage of useMemo. I didn't know this, but the React team has made a lot of progress on the React compiler, which takes care of memoization for you automatically. There's a release candidate that's stable enough for our needs, and I'm happy to use it. The only catch is that it doesn't work with Vite plugin React SWC, which is built in Rust. And if you were using it like me, with your project scaffolding, you'll have to switch to Vite plugin React, which is based on Babel. It's very quick to do, just something to be aware of. The third refactor is very minor. My custom hooks, use player animations, and use player controls were getting too long to scroll around comfortably, so I moved them to their own files. Okay, let's upgrade the movement controller. We want to use the pointer positions from the new RaycastPlane component to make 2 changes. 1, we want to rotate our character based on the pointer position for keyboards, and 2, we want to move and rotate our character with finger dragging on touchscreens. Sounds simple, and it actually is. We just have to be mindful that my controller supports 8 directions of movement, so we have to quantize or snap the rotation to 45-degree increments. We also want smooth transitions between the 8 different angle ranges. To accomplish this, we bucket the raw angle of rotation, then instead of setting the rotation immediately, we used a lerp, or linear interpolation helper, to move gradually from the starting angle to the target one. Previously, the logic for selecting the right run animation was specific to the initial rotation of the models, so I made it more general. I also added a bit of a margin to prevent the model from flashing between two animation states at the border between any two angle ranges. With the rotation logic now in place, adding touchscreen support is very simple. All we have to do is move forward if the user is dragging, and that's the demo. Don't forget to check it out in the description, and if you haven't already, make sure to subscribe to get the next episode. If you'd like to see the full source code for this playtest, and for all the other ones past and future, to really understand how features get implemented and changed or refactored over the lifetime of making a full game, the code is available for anyone that supports me on Patreon right now, or on YouTube once we have 1,000 subscribers. Speaking of subscribers, I want to thank all of you who subscribed to the channel after my very first uploads from last weekend. It was a happy surprise because I didn't think I'd get any views until after episode 5 when I start working on the more visual and eye-catching parts of the game. I really appreciate your support so early, and if you have any feedback on my content, I'd be happy to hear. Things I should spend more or less time talking about, video editing, which I'm still figuring out, and so on. I'm also thinking about making individual tutorials for all the topics that come up in these devlogs. Let me know if that's something you'd want to see. You might have noticed that while our keyboard players can move in 8 directions, touchscreen players only have forward movement, which means keyboard players have an advantage with finer-grained control, and that raises some game design considerations. In my case, I have several concrete design goals. I want a MOBA-like experience, but for dueling, so no PvE units like minions and towers. Combat will be based on abilities only, so no auto attacks, and the game will revolve around sword fighting. These constraints mean that I can address the movement advantage by balancing classes that have fast movement and weaker attacks with smaller hitboxes, which might only be played by keyboard players, against classes with slower movement and stronger attacks with large hitboxes, which can be enjoyed by touchscreen players too. There's a lot more to share on these concepts, but that will come later when I work on the combat system. For now, my focus is on 2 goals: integrating the player controller with the hex grid, and moving my animation logic to a state machine. If you're making a single-player game, the character controller works great as is, and you can tweak the movement speed and transition curves as you see fit. But if you want to do multiplayer like me, you'll want something where the state is easier to sync across the network. And if I keep building as is, you would see an explosion of complexity with each additional feature I add, to the point that it would be very difficult to implement multiplayer, let alone all of the combat interactions I'm planning. Those interactions will trigger all kinds of animations, so I'll also want a more robust way of handling them, and you'll see me use state machines for that. Thankfully, many smart game developers have made games before us, and they've come up with a useful architecture pattern called an entity component system. Adopting an ECS will help me keep game features decoupled, which will keep the codebase manageable, and help ensure that I can distill my game features into an efficient wire format for multiplayer. Next episode, I'll be placing the characters and hex grid system in the same virtual world by introducing an entity component system. This architecture and how I apply it will directly facilitate determinism in the game simulation and greatly simplify both the combat system and multiplayer netcode that I have in mind. And after the next episode, we'll get into the visual side of things. See you next time.